Ancient builders achieved precision that our modern lasers cannot match. This journey through 25 lost technologies will reveal how civilizations mastered their world in ways we still cannot explain. You will discover forgotten principles that could reshape our future. Why did the knowledge behind self-healing concrete and nanotechnology infused glass vanish for centuries? What does our struggle to rebuild these marvels say about progress itself? How much of human achievement is truly permanent? In the dim waters off a Greek island, sponge divers stumbled upon a shipwreck in 1901, completely unaware they were about to pull a rusted lump of history from the seabed. This corroded bronze artifact, now known as the Antikythera Mechanism, had rested in silence for 2,000 years. When researchers finally peered inside, they found not a simple relic, but a labyrinth of over 30 precisely interlocking bronze gears. It was a mechanical calendar for the cosmos, predicting planetary movements, solar eclipses, and even the 4-year cycle of the Olympic Games with a precision that should not have existed in its time. Advanced imaging techniques like X-ray tomography revealed its most startling secret, a system of differential gears. This technology was so advanced that historians believed it was not invented until the 16th century, over a millennium and a half later. The craftsmanship suggests this was not a one-of-a-kind miracle, but a product of a sophisticated tradition of mechanical engineering, a tradition that vanished completely from the historical record. What happened to the knowledge that built this ancient computer? Did it perish with its creators, or was it lost in the slow collapse of empires? The silence that followed its disappearance is as profound as the device itself, leaving us to wonder what other mechanical marvels were lost to time. This profound gap in our understanding of ancient innovation leads us to a mystery carved in stone, one that stands defiantly against the desert sky. The dome of the Roman Pantheon has defied the centuries without a single reinforcing rod. Its vast, unbroken expanse of concrete has endured for nearly 2,000 years, a silent rebuke to our own crumbling modern infrastructure. While our bridges and buildings often show significant wear within just 50 years, these ancient structures seem to grow stronger with age. The secret was in their unique recipe, a formula lost for over a millennium. Roman engineers did not simply mix sand and cement. They combined volcanic ash, lime, and fragments of rock, then mixed it all with seawater. This unusual combination triggered a chemical miracle. Over time, seawater filtering through the concrete caused rare minerals like aluminous tobermorite to crystallize, actually blocking cracks and reinforcing the material from within. Modern scientists using powerful electron microscopes have uncovered an even more astonishing feature. The Romans used a process called hot mixing, incorporating quicklime directly into the mixture. When tiny cracks eventually form, rainwater reacting with this leftover quicklime creates a healing gel of calcium carbonate, seamlessly sealing the fissure shut. Our modern concrete lacks this self-repairing ability entirely. It is brittle and passive, while Roman concrete was a living, reactive material. So why was this revolutionary formula forgotten? The knowledge likely faded during the political and economic instability that marked the transition into the Middle Ages, a period when large-scale public building projects ceased and specialized trade secrets died with their masters. The enduring presence of these structures forces us to reconsider what true technological progress really means. If we could build with the foresight of the Romans, our cities might last for millennia. This mastery of material science is not unique to Rome, however. Another civilization far across the world manipulated stone with a precision that seems equally impossible. Medieval crusaders returned from the Holy Land with incredible tales. They spoke of swords wielded by Islamic warriors that could cleave through European armor and yet remain flexible enough to bend from hilt to tip. The surfaces of these legendary blades shimmered with watery, swirling patterns, a visual signature that seemed as magical as their performance. This was Damascus steel, a metallurgical marvel produced for over 1,000 years. The secret began not in Syria, but with cakes of iron known as wootz steel, imported from India and Sri Lanka. Ancient smiths would melt this raw material in sealed clay crucibles, carefully controlling the carbon content and the incredibly slow cooling process in a specific thermal cycle. The result was a steel with a unique internal architecture, a complex matrix of ultra-hard cementite and softer, more flexible phases that gave the blade its legendary sharpness and resilience. For centuries, the full recipe remained a mystery. Then, modern science peered into its soul. Using powerful electron microscopes, researchers made a stunning discovery. Embedded within the steel's microstructure were carbon nanotubes and cementite nanowires. These microscopic structures, only identifiable with 20th century technology, acted as a natural reinforcement, giving the steel its extraordinary properties. Somehow, these ancient craftsmen were manipulating matter at the nanoscale, achieving a level of material science that should have been impossible for their time. Yet, by the mid-18th century, the knowledge was gone. The specific ore sources were depleted or lost, and the precise, almost ritualistic forging techniques faded from memory. Despite our best efforts with modern laboratories and advanced analysis, we have never fully replicated the original process. The loss of Damascus steel is a haunting reminder that technological peaks can be isolated, and that supreme skill is not always a permanent human possession. This ancient mastery of materials finds a strange parallel in another part of the world, where a different civilization achieved a feat of manufacturing that seems to defy the very tools they had available. Aboard a Byzantine warship in the 7th century, a terrifying new weapon changed the face of naval warfare. It was a liquid flame that could be sprayed from bronze tubes, a fire that danced and roared even across the surface of the sea, defying all attempts to quench it with water. This was Greek fire, a technological secret so powerful it secured the Byzantine Empire's survival against overwhelming odds for centuries. Its development around 672 CE provided a psychological and tactical advantage that was nearly absolute. Enemy sailors could only watch in horror as a jet of fire would arc towards their vessel, clinging to the wood and sails, creating an inextinguishable inferno. Historical accounts describe its terrifying properties, a substance that seemed to almost come alive on the water, creating a barrier of flame that could not be crossed. The true composition of this ancient napalm remains one of history's most enduring chemical puzzles. Historians and chemists have pieced together clues from fragmented texts, suggesting a complex mixture that may have included crude petroleum, quicklime, sulfur, and possibly even saltpeter. The most compelling theory involves a reaction between quicklime and water, which generates immense heat and could have triggered the ignition of other petroleum-based components upon contact with the sea. This would explain the reported spontaneous combustion and the inability to douse the flames with water, as doing so would only feed the chemical reaction. Modern attempts to recreate Greek fire based on these descriptions have yielded flammable substances, but nothing that truly matches the historical accounts of a sticky, persistent, and water-resistant firestorm. The secret was not just in the ingredients, but in a precise and guarded manufacturing process, a formula known only to a select few. The Byzantine emperors treated this knowledge as the ultimate state secret, comparable to a modern nuclear code. The formula was so closely held within the imperial family that it was never written down in a complete form, passed orally from one generation to the next. This extreme secrecy was its greatest strength and ultimately the cause of its permanent loss, as the empire faced periods of great turmoil and eventual decline. The chain of custody for this sacred knowledge was broken. The individuals who understood the precise ratios, the specific preparation methods, and the handling of the volatile components passed on without successors. By the time Constantinople fell in the 15th century, the technology had already faded into legend. The loss of Greek fire forces us to consider a profound question. How many other sophisticated chemical processes, born from generations of observation and experimentation, have vanished without a trace, their potential benefits lost to all future generations? This mastery of volatile elements stands in stark contrast to another ancient wonder, one that demonstrates a completely different kind of control over the natural world. These towering walls at Sacsayhuaman are a puzzle carved in stone, a testament to a building technique that seems to defy physical logic. Massive blocks, some weighing as much as 200 tons, are locked together in a complex, interlocking jigsaw. The joints are so seamless that they reject even the thin blade of a razor, a perfect fit achieved entirely without mortar. The Inca accomplished this without the wheel, without iron tools, and without a written system to record their methods. How did they transport these colossal stones across treacherous mountain terrain, and then shape them with such microscopic precision? Some of the stone joints show contours so fluid they appear molded or softened, as if the rock itself was made pliable. This has led to fascinating theories, from the use of plant-based chemicals that could temporarily soften the stone's surface to the speculative idea of acoustic levitation, using sound waves to manipulate the massive blocks. Yet, no single theory fully explains the consistent perfection seen across thousands of individual stones. The most likely explanation points to an incredibly sophisticated, hands-on knowledge system passed down through generations of master craftspeople. They possessed an intimate understanding of geology, fracture points, and abrasion techniques, using harder stones to patiently grind and polish softer ones over countless hours. This was not magic, but a form of applied knowledge so refined it appears magical to us today. The true loss occurred during the period of European contact, when the societal structures and oral traditions that preserved this specialized knowledge were profoundly disrupted. The silent walls remain, challenging our deepest assumptions about the capabilities of pre-industrial societies and the fragility of human innovation. This incredible mastery of stone finds a curious echo in another part of the world, where an ancient culture developed a method of joining stone that was equally revolutionary and just as difficult to explain. The sheer scale of the Great Pyramid of Giza is a mathematical statement carved in limestone and granite. Its 2.3 million stone blocks, each averaging 2.5 tons, were positioned with a directional accuracy within a mere 0.05 degrees of true north. This is not the work of brute force, but of a civilization that had mastered geometry, astronomy, and logistics on a scale that defies easy explanation. The quarries show evidence of precise channel cutting to free the core stones, but the journey of these blocks is where the true mystery deepens. How were masses of stone, some weighing as much as 80 tons, transported from quarries miles away and then lifted to a height of nearly 500 feet? Theories of massive, winding ramps have been proposed, yet no significant archaeological trace of such colossal earthworks has ever been found. The logistics are staggering, a project requiring the coordination of tens of thousands of workers with a system of management so effective it feels modern. This suggests a body of knowledge around project management and engineering physics that was never written down in a form we can now recover. It was likely embedded in an oral tradition, passed from master builders to apprentices through generations of practice. The pyramid's internal structure reveals another layer of sophistication, with its cleverly placed relieving chambers above the king's chamber, distributing the immense weight of the masonry above, a testament to a profound understanding of load-bearing mechanics. Modern engineers acknowledge that even with our cranes, lasers, and software, replicating the pyramid's precision at this scale would be a monumental challenge. The organizational system alone, ensuring a consistent supply of materials, food, and housing for a massive workforce over decades, represents a lost science of human coordination. What formulas for calculating angles and trajectories did they possess that we can only infer from the perfection they left behind? The silence surrounding their most advanced techniques forces us to ask what other principles of construction management and large-scale engineering were discovered, applied, and then vanished from human use. This incredible command over the physical world finds a strange parallel in a technology that sought to command the very essence of life and death. Deep in the arid plains of Peru, the Nazca people confronted a paradox. They inhabited one of the driest places on Earth, yet their survival depended on a reliable water supply. Their solution was not to fight the desert, but to work with its hidden logic, creating an underground network of aqueducts known as puquios. These were not simple tunnels, but a masterclass in hydraulic engineering that has functioned for over 1,500 years. From high mountain sources, the Nazca channeled water through a subterranean labyrinth, using the natural pull of gravity to guide it to their settlements and agricultural fields. The most striking features of this system are the spiral stone openings that dot the desert landscape. These were not just access points, they were functional components of a brilliant design. As water flowed through the underground channels, these spirals acted like breathers, managing air pressure to ensure a smooth, consistent flow and preventing destructive vacuum locks that would have stalled the entire system. They also minimized evaporation in the brutal heat, a critical consideration in a land where every drop was precious. The true mystery that stumps modern hydrologists is how the Nazca located these underground water sources with such pinpoint accuracy. Without any modern surveying technology, they somehow mapped the subterranean rivers, understanding the land's hidden anatomy in a way we can only achieve today with advanced geological sensors. Each spiral opening served multiple roles: ventilation, access for cleaning and maintenance, and a testament to a holistic understanding of nature's forces. This was not just plumbing, it was a deep, symbiotic relationship with a harsh environment. What knowledge of geology and water divination did they possess that has since evaporated from human memory? The enduring functionality of the puquios forces us to reconsider what true sustainability means, demonstrating that ancient solutions can sometimes outlast and outperform our most complex modern infrastructures. This profound command over natural elements finds a bizarre counterpoint in a technology that seems to play by an entirely different set of physical rules. The open ocean presented a navigational nightmare for early seafarers, with the sun and stars often vanishing for days behind impenetrable cloud. Yet Viking longships crossed thousands of miles of this featureless water, reaching destinations like Iceland and Greenland with a consistency that defies simple luck. Their secret may have been a legendary tool mentioned in their sagas, the Solarstein or Sunstone. This was not a mythical object, but a practical crystal that could reveal the sun's position even when it was completely obscured. Modern experiments with a type of calcite crystal known as Iceland spar, found at Viking archaeological sites, have shown how it could work, By looking through the clear crystal and rotating it, a skilled user would see two overlapping images of the sky. When the crystal is aligned in the specific direction of the sun's hidden path, these two images merge into one of equal brightness, revealing a polarization pattern in the atmosphere that is entirely invisible to our eyes. This gave the Vikings a reliable celestial compass on the most overcast days, a tool far more advanced than the magnetic compass that would not become widespread in Europe for centuries. Their navigation was a complex art, combining observations of wildlife, wave patterns, and the stars with this sophisticated optical technology. The knowledge was likely passed down through generations of master pilots, an oral tradition of wayfinding that faded as newer instruments made the old skills seem less vital. The loss of the Sunstone's specific use is a profound reminder that a technology does not need to be complex to be revolutionary, and that some of the most elegant solutions can be forgotten simply because the context that required them changed. This mastery of the unseen forces of light finds a startling parallel in a field where ancient practitioners sought to master the unseen forces within the human body. A physician in ancient India would have understood the human body with a startling intimacy. The Sushruta Samhita, a foundational medical text composed around 600 BCE, describes a world of medicine where surgeons performed cataract removal, reconstructed noses, and even conducted cesarean sections with a sophistication that would not be common in Europe for another 2,000 years. This was not primitive medicine. It was a highly systematized science detailing over 120 specialized surgical instruments, from scalpels and forceps to probes and needles, all crafted for specific tasks. The text outlines more than 300 different procedures, demonstrating a profound knowledge of anatomy gained not from books, but from direct, hands-on examination. The descriptions of rhinoplasty are particularly striking, outlining a technique to reconstruct a nose using a flap of skin from the patient's cheek, a procedure that mirrors the principles of modern plastic surgery with an almost uncanny accuracy. But how did they manage such invasive operations without the benefit of modern germ theory? The answer lies in a forgotten pharmacopoeia. Ancient Indian surgeons utilized a variety of medicinal plants with proven antibacterial properties, creating natural sterilization methods that dramatically reduced the risk of infection. They understood the importance of wound care and used substances like honey and turmeric, whose healing qualities are still recognized today, to promote clean recovery. This entire medical system, built on generations of meticulous observation and practical innovation, represents a peak of human knowledge that was not surpassed for centuries. The loss of this sophisticated tradition was not a single event, but a gradual erosion. Periods of foreign conflict and profound cultural disruption over the centuries caused the specialized knowledge, once passed from master to apprentice, to fragment and eventually fade from mainstream practice. The detailed understanding of surgical techniques and the specific applications of countless medicinal plants were casualties of this slow forgetting. This raises a haunting possibility. How many other advanced medical protocols, effective treatments for ailments we still struggle with today, were discovered by ancient civilizations only to be lost in the shadows of history, their potential benefits vanishing with the societies that cultivated them? This profound loss of biological knowledge stands in stark contrast to another ancient mystery, one that seems to draw its power not from the body, but from the very air itself. In 1936, within a dusty archaeological site near Baghdad, a simple clay jar was unearthed that would ignite a century of debate. The artifact, dating from the Parthian era between 250 BCE and 250 CE, was far from ordinary. Inside the unassuming vessel, researchers found a copper cylinder housing an iron rod, and both showed clear signs of corrosive residue from an acidic substance. To the trained eye of a modern engineer, this was not just a storage container. It was the basic blueprint for an electrochemical cell. When filled with a common acidic electrolyte like vinegar or grape juice, this assembly could have generated a small but measurable electrical current, around 1 to 2 volts. Replicas built based on its design have proven functional, capable of tasks like electroplating a thin layer of gold onto a silver surface. This simple process would have seemed like magic, transforming the appearance of an object through invisible forces. The existence of such a device forces us to reconsider the technological landscape of the ancient world. Was this a tool for artisans, an apparatus for healers who believed in the therapeutic power of a mild electric shock, or perhaps a ritual object used to create a mysterious sensation during religious ceremonies? The fact that we may never know its true purpose is as significant as the object itself. It suggests a branch of practical knowledge that existed outside the mainstream historical narrative, a spark of understanding that flickered and then went out. If these clay jars were indeed primitive batteries, what other simple yet profound electrical applications were developed and then forgotten, leaving no trace for us to find? This glimpse into ancient electrical potential connects to another material mystery, one that involves transforming a common substance into something almost supernatural. In the year 132, a court official named Zhang Heng presented the Han Dynasty emperor with a device that seemed to defy the very nature of perception. It was a large, ornate bronze vessel encircled by 8 dragons, each poised above a corresponding bronze toad with its mouth agape. This was not merely a ceremonial object, but the world's first known seismoscope. Its purpose was to detect the subtle, unseen tremors of earthquakes occurring hundreds of miles away. When a distant quake struck, an internal mechanism would trigger one of the dragons to release a heavy bronze ball directly into the mouth of the toad below with a resonant clang. The specific dragon that released its ball indicated the cardinal direction of the seismic event. Historical records from the era document its stunning accuracy, once correctly identifying an earthquake to the west that had not yet been felt at the capital. The genius of the device lay in its internal design, which most scholars believe housed an inverted pendulum. As seismic waves traveled through the earth and reached the vessel, the pendulum would swing, striking a lever mechanism that opened the jaw of just one dragon. This precise directional sensitivity, achieved without any understanding of modern wave theory, is what continues to baffle and impress seismologists today. Replicas built based on historical descriptions have proven remarkably effective, yet the exact internal configuration Zhang Heng used remains one of history's great engineering puzzles, as no original has survived. The loss of such a sophisticated early warning system speaks to the fragility of specialized knowledge. It forces us to wonder how many other brilliant monitoring devices, designed to anticipate natural events, were conceived and then forgotten during eras of upheaval. This ancient pursuit of stability in a shifting world finds a powerful echo in the very bones of old structures, which seem to possess a secret knowledge of how to dance with the earth. High above the Japanese landscape, a 5-story pagoda sways like a graceful reed in a storm. During violent earthquakes that level modern concrete buildings, these ancient wooden towers have danced with the tremors for over 1,400 years, never falling. Their resilience is not an accident of history, but the product of a profound and forgotten science. These structures were engineered without a single nail, relying instead on a complex system of interlocking wooden joints that allow the entire building to flex and move as a single, unified entity. Each story is built almost as a separate box, stacked upon the one below with a flexible connection. This brilliant design prevents the dangerous whiplash effect that can shatter a rigid building, allowing the pagoda to absorb and dissipate the Earth's violent energy through its very bones. The most ingenious feature, however, lies at its heart, a massive central pillar known as the Shinbashira. This thick wooden column is not a load-bearing pillar in the conventional sense. It is suspended from above, hanging freely through the center of the structure, acting as a colossal, stationary pendulum. As the pagoda sways around it, this central pillar counteracts the motion, stabilizing the entire tower like a steadying hand. Modern engineers recognize this as a form of tuned mass damping and base isolation, principles we have only recently begun to codify with complex mathematics and computer models. The master builders who conceived this system possessed an intuitive, generational knowledge of structural dynamics, a wisdom passed meticulously from artisan to apprentice. This was a living science, refined through centuries of observing how wood behaves under stress and how forces flow through a building. The knowledge was not written in textbooks, but in the precise angles of joints and the careful selection of materials. As Japan modernized and traditional carpentry guilds diminished, the deepest nuances of this seismic wisdom, the subtle rules of thumb for different soil types and wind loads, likely faded away. We are left with the magnificent, enduring result, but not the complete mental library that produced it. What other architectural secrets, born from 1,000 years of trial and error, have been quietly forgotten in our rush toward new materials and methods? This deep understanding of physical forces finds a parallel in an ancient device that sought to map the forces governing the cosmos itself. Deep within the humid jungles, Mayan astronomers charted the cosmos with a precision that feels almost supernatural. Their long-count calendar, perfected over centuries, was not merely a way to mark days, but a grand, interlocking machine of time. It synchronized the solar year, the orbit of Venus, and the phases of the moon into a harmonious rhythm, all calculated without telescopes or even the concept of zero as we know it. They achieved this with a base 20 numerical system, using only simple shells and dots to perform calculations involving numbers in the millions. The result was a measurement of the solar year accurate to within minutes of our own modern computations, a feat European astronomy would not match for hundreds of years. This was not stargazing, it was a highly formalized science, a complex body of knowledge that understood celestial cycles on a grand scale. The tragic loss of this system is one of history's great intellectual catastrophes. During the period of Spanish colonization, countless bark paper codices containing the full breadth of Mayan astronomical and mathematical knowledge were systematically burned as pagan texts. Only 4 major codices are known to have survived this cultural firestorm. What we understand today is a reconstruction from these fragments and the inscriptions on stone monuments, a mere echo of the original scholarly tradition. The silence left behind is deafening. It forces us to wonder what other profound insights into the nature of time, mathematics, and our place in the universe were consumed in those flames. This staggering loss of a complete scientific world stands in stark contrast to a different kind of ancient mastery, one that operated on a breathtakingly small scale. The Lycurgus cup seems to hold a captured beam of light within its very structure. In the ambient light of a room, this 4th century Roman chalice glows with a deep, opaque jade green. But hold it up to a direct light source and the magic reveals itself, the glass transforming into a translucent, glowing ruby red. For centuries, this appeared to be a mere optical illusion, a beautiful trick of the light. Then modern science looked closer, and the truth proved far more astonishing. When researchers examined slivers of the glass under powerful electron microscopes, they discovered the Romans had been practicing a form of nanotechnology. The glass is embedded with a precise mixture of gold and silver nanoparticles, each measuring about 70 nanometers in diameter. At this infinitesimal scale, the particles interact with light in a quantum mechanical dance. They scatter green light when illuminated from the outside, but allow red light to pass straight through when lit from within. This is not a simple dye or pigment. It is a sophisticated manipulation of matter at the atomic level, a technology we thought we invented in the 20th century. The manufacturing process is what truly baffles engineers. How did Roman artisans, working over 1,600 years ago, achieve such consistent control over particle size without any means of observing the results? They had no concept of nanometers, no electron microscopes to verify their work. The prevailing theory suggests they may have created a colloidal suspension of finely ground gold and silver dust in molten glass, then used a meticulous and precisely timed heating and cooling cycle to control crystal growth. This was a recipe born from generations of patient observation and experimentation, a secret so refined it was lost with the decline of the Roman glassmaking industry. The cup stands as a solitary relic of a material science that should not have existed. It forces us to ask a deeply unsettling question. If they could engineer glass at the quantum level, what other material technologies did they possess that left no trace behind? This mastery of materials on a miniature scale finds a dramatic counterpoint in a technology designed to move objects of almost unimaginable size. The silent stone giants of Easter Island stand with their backs to the sea, a line of colossal figures guarding a forgotten secret. Each Moai, carved from compressed volcanic ash, weighs as much as 82 tons, and they were moved for miles across the island's rugged landscape. The mystery is not just their size, but the complete absence of any clear evidence for how it was done. This was a society without the wheel, without draft animals, and without metal tools. So how did they transport these multi-story statues? One compelling theory suggests the islanders used a technique called walking. By carefully rocking the statue from side to side while teams pulled on ropes, they could have created a shuffling, upright gait that made the Moai appear to walk across the land. This method, demonstrated in modern experiments, requires a precise understanding of balance and rhythm, turning the statue's own mass and center of gravity into an advantage. Another hypothesis involves a sophisticated system of wooden sleds and lubricated tracks, using the island's precious timber to create a smooth pathway. The true engineering marvel, however, was not the physical act of moving one statue, but the organizational system that allowed for the movement of nearly 1,000 of them. It was a colossal logistical undertaking requiring the coordinated labor of hundreds of people, advanced rope-making skills, and a deep, intuitive knowledge of physics. This level of social organization and engineering sophistication completely contradicts the outdated narrative of a primitive society collapsing from mere resource mismanagement. They were not naive, they were masters of their environment, possessing a specialized knowledge system perfectly adapted to their unique challenges. The loss of this knowledge is inextricably linked to the profound ecological and social changes the island later experienced. As the environment transformed, the societal structures and the specialized guilds of engineers and carvers that possessed this transportation lore eventually faded away. The methods for moving the giants, a peak of human ingenuity born from isolation, were lost completely. This raises a haunting question for our own globalized world. What complex systems of knowledge do we possess today that are so specialized they could vanish entirely if the society that supports them were to change beyond recognition? This profound loss of a practical art finds a strange parallel in the ancient world of medicine, where another civilization developed a method for relieving suffering that was equally effective and just as mysterious. A patient lies fully conscious on an operating table, conversing calmly with surgeons as they perform a complex abdominal procedure. This is not a scene from a futuristic hospital, but a reality documented in ancient Chinese medical texts dating back over 2,000 years. Surgeons utilized a system of fine needles inserted at precise points on the body to create a state of profound anesthesia, allowing for everything from limb amputations to internal surgeries without the chemical cocktails we rely on today. This was acupuncture anesthesia, a pinnacle of traditional Chinese medicine that demonstrates a sophisticated mapping of the human body's internal communication network. The physicians understood that specific points along invisible pathways, which they called meridians, could influence physical sensation in distant parts of the body. By stimulating these points with needles, they could effectively block pain signals from reaching the brain, leaving the patient alert yet free from suffering. Modern neuroscience has begun to unravel how this might work, identifying the release of natural pain-killing chemicals like endorphins, the modulation of nerve signal transmission, and observable changes in brain activity patterns during treatment. Yet the complete physiological picture, the exact cascade of events that allows a simple needle to silence surgical pain, remains a compelling mystery. This was not mere folk medicine, it was a highly developed technology of the body, built on generations of meticulous observation and practical application. The knowledge represented a complete, alternative understanding of human physiology, one that viewed health as a balance of energy systems rather than just a mechanical functioning of organs. Over centuries, particularly during intense periods of cultural exchange and the push toward modernization, the deepest nuances of this practice, the specific protocols for different surgical procedures, and the intimate knowledge of subtle energy flows were fragmented. Some aspects were lost, while others were transformed as they merged with different medical systems. The existence of such an effective, non-chemical form of anesthesia forces us to reconsider the very boundaries of medical science. It prompts a profound question about the other forgotten healing arts that ancient traditions may have perfected, protocols for treating ailments that still challenge us, whose principles have faded into history without a trace. This mastery of the body's own systems through subtle intervention stands in stark contrast to a building material that seems to defy the body's most fundamental limitations. High atop the Pyramid of the Sun, builders sealed away a secret not of gold or jade, but of a shimmering, translucent mineral. The ancient metropolis of Teotihuacan is a geometric marvel, its grand avenue of the dead aligned with celestial precision. Yet one of its most puzzling features lies buried within its largest structure. There, sandwiched between two of the pyramid's construction layers, archaeologists uncovered two colossal sheets of mica, each spanning an astonishing 90 square feet and weighing several tons. This was no accidental inclusion. Mica is a complex silicate crystal, prized in our modern world for its exceptional ability to insulate against electricity, resist intense heat, and even block certain types of radiation. The sheer effort involved in its procurement defies belief. The nearest known source for mica of this quality and size is 2,000 miles away, in the distant mines of Brazil. Transporting these delicate, wafer-thin sheets across such a vast distance, through jungles and over mountains, without shattering them was a logistical triumph in itself. Why would a civilization without any apparent need for electrical components go to such extraordinary lengths? Was the mica used as a massive thermal regulator, somehow stabilizing the pyramid's internal temperature? Or did it serve a more esoteric purpose, perhaps related to energy we no longer understand or a ceremonial function lost to time? The builders left no written records to explain their reasoning, only the silent, gleaming evidence of their work. This sophisticated application of a highly specialized material suggests a knowledge of physical properties that we typically attribute to much later eras. It forces us to confront a startling possibility. The technological landscape of the ancient world may have included branches of materials science that pursued paths completely different from our own, paths whose purposes have become utterly opaque to us. This mysterious manipulation of a mineral's latent properties finds a resonant echo in a technology that mastered a far more ethereal medium, the invisible energy of sound. The voice of an actor on the stage of Epidaurus could travel with perfect clarity to the very last of its 14,000 seats, a distance of nearly 200 feet, all without a single microphone. This was not a matter of luck, but of architectural genius. The ancient Greeks designed their open-air theaters with a mathematical precision that modern acoustic engineers still study with a sense of awe. The secret lay in the perfect semicircular layout and the exact angle of the stepped limestone seats. Each row of seating acted as a filter, breaking up and absorbing the low-frequency rumble of background noise like wind and crowd murmur, while the hard, smooth surface of the stone steps reflected the higher frequencies of the human voice, carrying the crisp consonants and clear vowels directly to the listener. Even the positioning of the stage and the orchestral area was calculated to create a natural sound lens, focusing the performance outward. Modern digital simulations confirm that the dimensions of these theaters create an acoustic phenomenon where sound waves are reinforced rather than simply bouncing around, a principle we now understand through complex wave physics. The builders of Epidaurus possessed an intuitive, almost magical understanding of how sound behaves in a space, a knowledge so complete it was lost for centuries. During the Roman era and the subsequent Middle Ages, this specialized architectural science faded as building priorities shifted toward enclosed structures and different aesthetic ideals. The full design principles, the precise ratios and formulas passed from master architect to apprentice, vanished from common practice. We are left with the silent, empty theaters, their perfect acoustics a haunting echo of a science that was clearly understood and then forgotten. This profound loss forces us to question what other sophisticated principles of physics were embedded in ancient monuments, their purposes now completely opaque to us. From this mastery of sound, we turn to a different kind of ancient genius, one that coaxed life from the most unlikely and challenging environments. 6,000 years ago, beneath the relentless Mesopotamian sun, Sumerian engineers performed a kind of magic. They coaxed the twin rivers to surrender their water, weaving complex networks of canals and dams that turned a dry plain into the world's first breadbasket. This was not simple ditch digging, it was high-level environmental engineering. Their systems included adjustable water gates made of wood and stone to control flow, and feeder canals designed with specific gradients to maintain a consistent current without eroding the banks. They even understood the problem of sedimentation, building settling basins that allowed silt to drop out before the water entered the smaller distribution channels, preventing their intricate network from clogging. This mastery of hydrology supported populations dense enough to invent the wheel, writing, and the concept of the city itself. Modern analysis of these ancient sites reveals an even deeper genius, a solution to a problem that still plagues farmers today: soil salinity. The Sumerians developed a sophisticated practice of fallow rotation and strategic flushing, using controlled canal overflows to leach harmful salts from the soil and maintain its long-term fertility. The knowledge required to build and, just as importantly, to perpetually maintain these systems represented a pinnacle of collective human effort, a specialized science passed down through generations of water overseers. This hard-won understanding did not vanish in a single cataclysm, but eroded over centuries of conflict and shifting power. As empires rose and fell, the centralized authority and communal coordination needed to manage the canals fragmented. The specific technical protocols for calculating water flow, for determining the ideal slope of a canal, and for managing salt buildup were gradually forgotten. The canals silted up, the fields returned to desert, and the cities were abandoned to the sands. The loss of this integrated water management philosophy forces a difficult question. How many other sophisticated technologies for living in balance with a challenging environment have we misplaced over the long march of history? This ancient command over elemental forces finds a parallel in a manufacturing technique that produced objects of almost supernatural precision and endurance. The walls of a Shang dynasty bronze vessel feel impossibly thin, a metallic whisper from a world that perfected ritual through engineering. These were not crude cauldrons, but technological masterpieces cast with walls often thinner than a modern coin, sometimes measuring a mere 1 to 2 millimeters thick across their entire surface. Their surfaces shimmer with intricate patterns of Tauti masks and thunder spirals, designs so precise they seem etched rather than cast. This miracle of consistency was achieved through a revolutionary technique known as piece mold casting. Unlike the lost wax method used elsewhere, Chinese artisans would create a master model of the vessel in clay, then carefully section this model to produce multiple interlocking internal molds. These pieces were fired into terracotta, reassembled around a core to create the hollow interior, and then molten bronze was poured into the narrow gap between them. The result was a vessel that required minimal finishing, its decoration cast directly into the surface with a clarity and sharpness that defies its age. Modern metallurgists attempting to replicate this process face a cascade of challenges. Achieving such uniform thinness without the bronze cooling too quickly and creating weak spots or failing to fill the mold entirely seems nearly impossible. The ancient founders clearly possessed a secret understanding of their material. They used specific alloy compositions of copper, tin, and lead that provided the perfect balance of fluidity and strength, and they must have controlled the cooling process with a ritualistic precision, perhaps burying the hot castings in specific types of sand or ash to manage the thermal stress. This was not a single invention, but a cumulative science, a body of knowledge built over generations of anonymous masters who passed down the exact recipes for the clay mold material, the ideal pouring temperature, and the mysterious annealing process that followed. This profound metallurgical tradition did not disappear in a sudden collapse, but faded gradually. As the nature of ritual changed and iron became the dominant metal for practical use, the demand for these magnificent bronze vessels waned. The specialized guilds that guarded these complex recipes slowly dissolved, and the meticulous, step-by-step knowledge was scattered and forgotten. We are left staring at these impossibly elegant objects, wondering what other formulas for manipulating metal were lost in the quiet shift from one age to the next. This deep, almost alchemical understanding of materials suggests that ancient artisans could perceive properties in matter that we can only measure with our most advanced instruments, a concept that finds a startling resonance in the next mystery, where the manipulation of natural forces appears to defy our understanding of physics itself. A single man working in secret under the cover of night achieved what should have required a team of engineers with heavy machinery. Between 1923 and 1951, Edward Leedskalnin single-handedly quarried, transported, and erected over 1,100 tons of oolitic limestone to build his enigmatic coral castle in Florida. The blocks themselves weighed up to 30 tons each, yet he claimed he never used any modern-powered equipment, only a collection of simple hand tools. When questioned, Leedskalnin would only offer a cryptic explanation, insisting he had uncovered the secrets of the ancient Egyptians and the builders of the pyramids, principles he described as an intimate understanding of magnetic currents and the laws of weight. He spoke of manipulating the fundamental forces that hold matter together, suggesting he could make the massive stones virtually weightless. On the rare occasions he was observed moving a block, witnesses reported seeing only a tripod of old telephone poles and what appeared to be a simple chain hoist, a setup entirely insufficient for the task by conventional physics. Modern analysis has proposed theories involving brilliant leverage, hidden counterweights, or a novel application of permanent magnets, yet no proposed model convincingly explains his solitary success. The true mystery lies in the connection he himself drew to a forgotten past. His claims force us to consider a startling possibility. What if the methods used to build the world's most ancient monuments were not brute force and endless manpower, but a sophisticated, alternative understanding of physical laws, a practical science that viewed gravity and magnetism not as immutable forces, but as currents that could be channeled? Leedskalnin took his precise methods to his final resting place, leaving behind a modern monument that echoes the silence of the pyramids. This idea of harnessing unseen energies resonates powerfully with another ancient technology, one that seemed to draw power directly from the air itself. Sanskrit texts speak of Vimanas not as chariots of the gods, but as intricate machines with precise blueprints for flight. The Samarangana Sutradhara details construction down to the melting of metals and the assembly of engines powered by heated mercury, describing a craft that could soar vertically, hover motionless, or dart horizontally across the sky. The language used is not purely poetic, it is startlingly technical, mentioning components that resonate with modern aerospace principles. Some researchers point to passages that could be interpreted as describing gyroscopic stabilization for balance or even forms of ion propulsion, where charged particles create thrust. To the modern engineer reading these accounts, the parallels are unsettling, suggesting a conceptual framework for flight that should not have existed for thousands of years. Mainstream scholarship rightly classifies these descriptions as part of a rich mythological tradition, allegorical stories meant to convey spiritual power rather than document physical technology. Yet the consistency and specificity across multiple ancient sources provoke a difficult question. Could these texts be a distorted echo, a cultural memory of a sophisticated technological understanding that was somehow lost? The knowledge, if it ever existed in a practical form, would have been incredibly specialized, maintained by a small class of philosopher-engineers. Such fragile wisdom is easily extinguished by the upheavals of time, its principles surviving only as the stuff of legend, their original meaning obscured. This forces us to reconsider the very nature of a lost technology. Perhaps the greatest losses are not of objects, but of entire paradigms, different ways of seeing and manipulating the world that vanish so completely we can only glimpse them through the veil of myth. From these soaring speculations of ancient energy, we descend to a technology rooted firmly in the earth, one that created plenty from the most challenging conditions. Scattered throughout the vast and seemingly infertile Amazon basin lie islands of profound fertility, dark earth so rich it has supported agriculture for centuries without any modern fertilizer. This is Terra Preta, the work of ancient civilizations who transformed the region's notoriously poor soil into a self-sustaining agricultural engine. They did not simply farm the land, they engineered it from the ground up, This anthropogenic dark earth is a complex recipe of charcoal, known as biochar, mixed with broken pottery, animal bones, manure, and compost, all combined in specific, purposeful ratios. The biochar acts like a microscopic coral reef within the soil, a porous structure that provides a perfect habitat for beneficial bacteria and fungi. These microbes thrive, breaking down organic matter and creating a continuous cycle of nutrients, effectively making the soil a living, breathing, and self-renewing system. Modern analysis reveals that this ancient practice is a form of highly effective carbon sequestration, locking vast amounts of carbon into the earth for millennia while simultaneously enriching it, a dual benefit our current climate and agricultural science struggles to achieve. The true loss lies in the specific, place-based knowledge of its creation. How did they know the perfect temperature for creating the biochar, or the exact mixture of ingredients needed to activate this microbial paradise? This was not a single formula, but a sophisticated understanding of local soil ecology, a wisdom passed down through generations and then abruptly severed. The population collapse that followed European contact in the Americas caused this deep agricultural science to fade into the landscape itself. We are left with the fertile evidence but not the instructional manual, a haunting reminder that the most advanced technology can be a way of life, not just a tool. What other systems for living in perfect symbiosis with a challenging environment were lost during similar periods of cultural disruption? This profound understanding of the living earth finds a powerful contrast in a technology that looked not to the soil, but to the stars for its ultimate alignment. 5,000 years ago, builders in Ireland raised a mound of earth and stone that captured a single, precise moment of the sun. Newgrange is a passage tomb older than the pyramids of Giza, a structure of such complexity that its greatest secret only reveals itself for a few fleeting minutes each year. At dawn on the winter solstice, as the sun crests the horizon, a narrow beam of light enters through a unique opening above the entrance known as a roof box. This sliver of light then travels down a 60-foot passageway, piercing the deep darkness to illuminate the central burial chamber for just 17 minutes before receding once more into shadow. This was not a happy accident of construction. It is a feat of architectural astronomy that required generations of observation. The builders needed to track the sun's slow migration along the horizon for decades to pinpoint the exact location of the midwinter sunrise. They then had to engineer a structure that would not only capture that light, but would maintain the alignment perfectly as the tons of stone and earth settled over the centuries. The roof box itself is a masterpiece of engineering, a specially constructed channel that filters and directs the sunlight with the precision of a modern optical instrument. This implies a formal, accumulated science, a body of knowledge about solar cycles, structural integrity, and geometry that was passed down through an oral tradition. The silence that followed this culture's decline is as profound as the monument itself. What other intricate understandings of celestial mechanics, encoded not in books but in stone, were lost during the great cultural shifts of prehistory? This mastery of aligning massive structures with cosmic events finds a curious parallel in a different kind of ancient creation, one that involved transforming humble materials into objects of unique and enduring function. The final lost technology unfolds not in stone or metal, but in the delicate, almost invisible thread spun by a caterpillar. For over 3,000 years, the Chinese Empire maintained one of history's most formidable technological monopolies, built entirely upon the secret of silk. The penalty for revealing the methods of sericulture to outsiders was death, a stark measure that speaks to the immense value of this knowledge. This was not merely a craft, but a complete, integrated system of biological and mechanical engineering. In specialized workshops, generations of masters cultivated specific varieties of mulberry trees, bred silkworms with desirable genetic traits, and perfected the art of reeling the fragile filament from the cocoon in a single, unbroken strand that could stretch for hundreds of meters. They developed intricate looms and mastered the chemistry of natural dyes derived from plants and minerals, creating colors so vibrant and fast they have endured for millennia. Modern textile engineers analyzing ancient silk samples are consistently impressed by the material's quality. The thread uniformity is astonishing, with a consistency in thickness that rival machines struggle to replicate. The weaving precision achieved entirely by hand, with thread counts so high they create a fabric that is both incredibly strong and beautifully lustrous, represents a peak of manufacturing expertise. The profound loss we face today is not the ability to produce silk, but the complete system of knowledge that surrounded its traditional creation. The nuanced understanding of silkworm life cycles, the secrets to the most resilient dyes, and the specialized hand-weaving techniques for the most complex patterns have been largely displaced by modern, industrialized methods. We can make silk, but we have forgotten how to make it with the same transcendent quality and consistency that the ancient Chinese masters achieved. This final example, a technology of softness and light, brings our journey to a close. It compels us to look back across all 25 marvels, from self-healing concrete to the quantum glass of Rome, and ask a single, haunting question. If so many peaks of human ingenuity could be scaled and then forgotten, what does that tell us about the permanence of our own civilization's achievements? The silent testimony of these lost technologies suggests that progress is not a straight line, but a fragile tapestry, and that threads of knowledge, no matter how strong, can still be severed by the slow erosion of time. These 25 marvels form a pattern far more profound than a simple list of curiosities. They sketch a different map of human history, one not of a steady upward climb, but of a landscape dotted with isolated peaks of genius, separated by deep valleys of forgetting. The common thread is not the technology itself, but the nature of the knowledge that created it. This was not knowledge stored in databases, but wisdom etched into the hands of artisans, passed from master to apprentice in a sacred chain of practical understanding. It was a science built on generations of patient observation, of watching how a stone fractures, how a metal cools, how a plant can heal, or how a star moves. These civilizations excelled at listening to the subtle language of the natural world, and then devising elegant, sustainable ways to work with its inherent logic. Their concrete grew stronger with time, their soil became more fertile with use, their buildings danced with earthquakes rather than resisting them. In many ways, their solutions embodied a principle of harmony that our own more forceful and resource-intensive technologies often struggle to achieve. So why did these brilliant systems vanish? The answer is rarely a single dramatic event. More often, it was a slow unraveling. The fragile ecosystems of specialized knowledge were vulnerable to the shocks of history. A period of conflict could scatter a guild of master builders. An economic collapse could erase the demand for a supremely crafted sword. A shift in political power could dismantle the institutions that maintained a vast irrigation network. The most profound losses occurred when an entire way of life, with its oral traditions and its intimate connection to a specific place, was profoundly disrupted. The knowledge did not become obsolete, it simply became orphaned, its guardians gone and its context lost. This pattern forces a difficult question about our own technological era. We live in an age of unprecedented data storage where information seems permanent, but are we any less vulnerable? Our own systems are incredibly complex and deeply interdependent. If the intricate network that supports our digital world were to falter, how much of our own advanced knowledge would remain truly accessible? The silent testimony of these lost technologies suggests that the greatest threat to progress is not a lack of innovation, but a failure of continuity. They serve as both a warning and an inspiration, reminding us that true advancement may lie not only in inventing the new, but in preserving the profound and timeless wisdom of the past.